Hey boys and girls, how are you? Hope you are well and safe. Yeah, this afternoon we're carrying on with our mathematics lesson. We're going to carry on with our trigonometry class as we have started some a few lessons before now. So today we'll be looking at angles on the Cartesian plane. So before we carry on again, my name again is Sado Jafaru Abdullahi. So our topic will still be trigonometry. Okay. All right, we're carrying on with our lesson as we have started with trigonometry. Right. So at the end of today's lesson, so we should understand, we should be able to understand the concept of Cartesian plane. So the angle on the Cartesian plane, we should be able to understand that. So, and apart from that, you must understand the concept of quadrants. Understand the concept of quadrants. So we have four types of quadrants. What about these four quadrants? What is it all about them? By the end of the class, you'll be able to understand the four quadrants, the type of angles in each quadrant. When will an angle go into a particular quadrant? You should be able to understand that. And then be able to solve simple trigonometric expressions and equations. All right. Right. So let's go gently. Right. So the angle in the Cartesian plane. So consider a circle. Consider a circle with center O. See, this is a circle at center O. Okay. And this circle have got a radius R. You know the circle R. Okay. And then with R on any point, so the R can go on any point along this circle. Okay. The radius on the circle at point R, and then they go all around. Meaning the radius can go all around as the angle increases. Okay. And then so the theta is an angle measured anti-clockwise from the positive side of the x-axis. So we think the radius can go all around in an anti-clockwise manner. Okay, there is clockwise, this is anti-clockwise. Okay, so we call this the terminal arm, called OR, the terminal arm. So call this the terminal arm, and then this theta is said to be at the standard position. Then it's set at the standard position. So if you have this kind of circle like this, okay, whereby this line or arc can move all around the circle as the angle increases. Okay, so and as the angle increases, now the radius moves, and then that will affect our values of our x and y. Okay, let's explain this in a simple language. Okay, now at point R has coordinates x and y. Okay, point R has coordinates x and y. That is the coordinates of point R on this what circumference. Okay, right. So now, if you try to create a line now, if we create this line here now, this line y, so that will imply that what our y value, our y value have this. I mean, all these coordinates are will be this. Will be the value of will be this line here. We try to create it. Well, try to complete this triangle here. So here we have our y. So the y coordinate here is our y here, and then the x coordinate of this r is what our x on this side of the triangle. Okay, so we're saying if you have a point like this, and then we are given the coordinates x and y, so we say the x, if you and if you complete a triangle like this was an arm, and then we say there's an angle. So with this an OR and an angle here, if you try to complete a triangle, if you try to complete a triangle, we're saying the value of this x, I mean your x coordinate here will be what will be here, because you can see this is your r. You expect that what this will be your x, maybe your x is 4, maybe your x is 4 and your y is 10. That means x is 4, the x coordinate is 4, right? That means from the origin is 4. That means from origin there is 4. So there will be our x value, and then this will be our y value when this triangle is created. Okay. So basically we're gonna have a triangle like this, and then we're gonna have there being our x and be our y. Okay. Right. So now, so what we're saying is, if you look at this here properly, you're gonna see that what that the value of our x will be positive. Here our x value will be positive, and then here our y value will be positive as well. When the line, when this terminal arm is in this what? Is in this part, is when the angle is between what 0 and what 90. Remember when this angle goes up this way, then it's what 90 degrees. Okay, but now, so once it's still within this 0 and 90, when it's between 0 and 90, we're saying what? That our value of x and y will always be positive. When it's between what 0 and 90, meaning when it's just within this first quadrant, we call it on the first quadrant. When theta is still less than 90, it's between 0 and 90, our value of x and y be positive. So now, if this terminal arm now opens, the angle now increase now anti-clockwise, and then it opens, it goes when bigger than 90. The theta goes beyond 90 and opens to this side of the Cartesian plane. So if you open this side of the Cartesian plane, so we're going to create our triangle as well. So we're going to see that on the next slide. Okay, let me show you the next slide and then you can see what she's talking about. Okay, still on that, still on the first triangle, still on this first part here, still on this here, we're saying the angle can increase anti-clockwise. So still here. So we can find our sine theta here, our cos theta, and our tan theta. Okay. So first of all, our x value, our y value will be positive. That's one thing. And then if you try to find your sine theta, this will be your theta, this is your hypotenuse, this will be your hypotenuse, this will be your opposite. Your sine theta here will be positive. In fact, all the three trig ratios will all be positive here in this first quadrant. Call this the first quadrant. So all our three trig ratios will be positive. We try to find your sine theta here now. Sine is opposite over hypotenuse. So we have what? Positive y over hypotenuse r. Okay, positive y over hypotenuse r. So that means y over r. So cos theta will be opposite by hypotenuse will be positive. So if we find cos theta as well, then the adjacent x over hypotenuse, which will be positive. Also, if we find tan theta also, tan will be what? Opposite y over adjacent x. Okay, so we're saying once this angle is less than 90 degrees, all the three trig ratios will all be positive. Again, once this arm is in this first quadrant, in this first quadrant where our theta is less than 90 degrees, because when you get to 90, so once it's less than 90 degrees, or if you try to find all your three trig ratios will all be positive. Okay, that is what we have on the next slide. Okay, on the next slide, for each point r, x, and y on the terminal arm of theta, the following trig ratios of theta can be defined. Okay, absent theta. Theta will be opposed by hypotenuse, which will be y over r. Cos theta will be adjacent over hypotenuse, which will be x over r. And our tan theta will be opposed by adjacent y over x. Remember our SOHCAHTOA we talked about before now in our previous lesson. Okay, right. So let's see now. Now, the Cartesian plane is divided into 4 quadrants. Then the Cartesian plane is divided into 4 quadrants. Okay, so the Cartesian plane again is divided into 4 quadrants. Let's refer to the first Cartesian plane we got here. So we think there are 4 quadrants basically. Okay, there are 4 quadrants. So this from 0 here, this x-axis here up to y here. So this here is the first quadrant between 0 and 90. We refer to it as the first quadrant. So there's the first quadrant. And then this from 90 degrees to 180 degree is second quadrant. And from 180 degree down this way is what third quadrant. So this here is 270. And from 270, again 90 degree up to 360 is what fourth quadrant. We have first quadrant, second quadrant, first, second, third, and fourth quadrant. Okay. Again, we're saying again that in trigonometry we have 4 quadrants. This meaning like the circle is being divided into 4 quarters. This is like the first quarter, what called the quadrant now, like divided into 4 portions. So we write it as quadrants. So this one is the first quadrant, then the second quadrant, then the third quadrant, and then the fourth quadrant. Okay, so how do we define the first quadrant? The first quadrant is what? Between angle 0 and 90 is the first quadrant. So if you have an angle that is between 0 and 90, then we say will go into the first quadrant. It will be in the first quadrant. And then the second quadrant is from 90 degree to 180 degree. So any angle between 90 degree and 180 degree will be in the second quadrant. Okay, any angle between 90 to 180 will be in the second quadrant. For example, if you get an angle of 120, 145, 145 degree will be in the second quadrant. 76 will be in the first quadrant. 179 will be in the second quadrant. So if you have angles between 90 and 180, it will be in the second quadrant. Okay. So from this other part of it, it's called the second quadrant. Okay. And then from 180 here to this side here to 270 degree, it's called the third quadrant. There is 180, there is a 270 degree. Okay. So angle between 180 is here. Remember that's the circle 180 to 270. Any angle between 180 and 270 will be in the third quadrant. So these are third quadrants. For example, angle 200. We say which quadrant does angle 200 fall in? 200 degree is in which quadrant? It must be in the third quadrant. Okay. Angle 243. 243 will be in which quadrant? Is third quadrant. Okay. And then the last quadrant, this here is the fourth quadrant. Okay, this part is the fourth quadrant. Okay, the fourth quadrant, and then is between for angles that are between 270 and 360. Remember, the full circle is what 360 degrees. All right. So from here to here is 90. From 90 to here is 180. From 180 to that is 270. 270 back here is 360. So between 270 and 360 is what the fourth quadrant. So any angle between 270 and 360 are said to be the fourth quadrant. Okay, so that's the concept of quadrants. Again, you have four quadrants. There is the first, there is the second, there is the third, there is the fourth. All right. So the first one is for angle between 0 and 90. The second one is for angle between 90 and 180. The third one is for angle between 180 and 270. And then the fourth one is for angle between 270 and 360. Okay, right. So we're saying again for the first quadrant, we say all the three ratios are positive. All the three ratios are positive, meaning any angle that goes into the first quadrant, if you find the sine of such angle, or the cosine of such angle, or the tangent of such angle, they will all be positive. That's by what? All the three ratios, all the three ratios in the first one are all positive, meaning the sine, the cosine, and the tan are all positive, as we can see there. That if you find sine theta there, sine theta will be y over r, opposite over hypotenuse, opposite over hypotenuse, cos theta adjacent to hypotenuse, and theta over adjacent. So all are positive. So all three ratios are positive. Okay, right. So let's see. And then to remember this quadrant thing, we simply use what we call what? Cast. We use a simple word, cast. Cast. Then this is our C. Then we have our C here by the first quadrant. And there we have our A. And then this is our S. The second quadrant is our X. And the third quadrant is our T. So cast. Spell from the first one from the bottom here. C-A-S-T. We simply use that C-A-S-T, cast. Okay, so what do you mean by cast? C-A-S-T. What do you mean by that? A here implies what? That all the three ratios are positive. That's the meaning of the A here. Again, cast. There's C here, there's A here, there's S here, there's T here. The A here stands for all. The A here stands for all, meaning all the three ratios are all positive. The S here standing for sign, meaning only the sign is positive here, and then this stands for tan, which means only the tan is positive. Okay, let's see as we go along the other slides, you understand better. Okay, so for the first quadrant, we see all the three ratios are positive. Okay, now Let's see on the next slide now. So we're saying the Cartesian plane is divided into 4 quadrants, allowing for the angles in the interval 0 to 360. Okay, angles in the first quadrant will lie in the interval 0 and 90. The first quadrant refers to angle between 0 and 90. Second quadrant will lie between 90 and 180 degree. Okay, and then the third quadrant is between 180 and 270 degree. And then the fourth quadrant, angles in the fourth quadrant will lie between 270 and 360. So those are the 4 quadrants we have. So if we have an angle, for example, an angle that says 285 will be in the 285 degrees. We fall into which of the quadrants? Into the fourth quadrant. Because 185 is between 270 and 360. Okay. If we have 109 angle, which quadrant would that be? We're going to be in the second quadrant because it's between 90 degree and 180 degree. Okay, these are some of the examples. Okay, let's see them. Let's see how this really, what this really means. So we're saying we have 4 quadrants. Okay, we call this the first quadrant between 0 and 90 degree. Okay, any angle between 0 and 90 degree, we say you're going into the first quadrant. And then any angle between 90 degree and 180 degree, we say it's in the second quadrant. Any angle between 180 degree and 270 degree is in the third quadrant. Any angle between 270 degree and 360 is in the fourth quadrant. Okay. Okay. Right. Fine. And then we say again that in the first quadrant, we name all these quadrants as casts. Fourth quadrant, I've got C. First quadrant is A. And the second quadrant is S. And the third quadrant is T. So it's cast. Okay. So cast. So where A here means what all the three ratios, sine, cosine, and tan, are all positive. Second quadrant, which have S, means only sine is positive, but the rest are negative. And then tan has T, which means only tangents of the angle that goes in here are positive, but the cosine and the sine will be negative. And then this fourth quadrant, which has letter C, it implies what? C stands for cosine. And that means that what only the cosine, only the cos of the angle that goes in here will be positive, the sine will be negative, the tan of such angle will be negative. Right. So let's see better them. Right. So now what you say basically that in quadrant one has angle between 0 and 90 degree. Quadrant has angle between 0 and 90 degree, and then our R is positive, our terminal R, our radius is positive, S is positive, Y be positive, and the sign will be what? Positive or positive, sign be positive, cosine be positive, tan be positive, meaning this is our first quadrant. So this first arm is our first quadrant. All the three ratios are positive. So meaning any angle that is between 0 and 90, angle between 0 and 90, if you find the sine of it, if you find the cosine of it, if you find the tangent of it, they will all give you positive answers. Okay. Okay. And then for the second quadrant, the same for the angle between 90 degree and 180 degree. That theta must be that element of 90 degree and 180 degree. And then in that case, you find that your R is positive, your X is negative. Your X is negative, but your Y is positive. So negative, so sine is what? The opposite over hypotenuse. So negative divided by positive. Negative divided by positive gives what? For the sine, negative divided by positive divided by positive will be positive. So in the second quadrant, basically, the second quadrant is this here. In this other side, you can see your terminal arm. Here is your terminal arm is on this second quadrant. But the second quadrant, our X value is negative. Our X value is negative because there is 0 at the center of origin. So this side there is negative, but Y is what? Positive. Okay. You're going to find sine of it. So sine will be opposite over, sine will be opposite will be what? Y over hypotenuse R. So it will be positive, Y will be positive there. Y is positive there, R is also positive. R is always positive. Our R is always positive signs. So we're saying sine, only the sine of the angle will be positive, basically. That any angle that falls between 90 degree and 180 degree only the sign of it to be positive. For example, let's take an example. If you have sine 110 degree, if you have like 10 degree, 110 degrees now, for example, say you have 110 degrees. So the question will be, which quadrant does 110 degrees falls? Which quadrant does 110 degree lies? So 110 degree will lie in the second quadrant. All right. So what we say is at the second quadrant, only sign is positive. Only sign is positive. Cosine, cos theta will be negative. Tan theta will be negative. Okay. So only sign is positive. There is sign, there is cosine, there is tan. So for the first quadrant again, sign is positive, cosine is positive, and tan is positive. Okay. For the second quadrant, sine is positive, but cosine is negative, but tan is also negative. Okay. Meaning what? Only sine is positive in the second quadrant. And by the third quadrant, within third quadrant is that quadrant that have angles between 180 and 270 degrees. So if you have angles within this range, 180 and 270 degrees, you're going to find out what? The sine of such angle will be negative, the cosine of such angle will be negative, only the tan will be positive. Meaning if there's any angle that lies between 180 and 270, right? For example, any angle, for example, say 200, you're going to find the sine of it to be negative. The cosine of it to be negative, the tangent, only the tangent of that 200 and 200 be positive. So if you in your calculator, if you punch sine 200, you get the negative value because 200 is in the third quadrant, and in the third quadrant only tan is positive. So if you find sine 200, you get negative answer. If you find cos 200, you get a negative answer. If you find what tan 200, you get what positive answer. Okay. And then for the fourth quadrant, say fourth quadrant is that quadrant that are in between 270 and 360. So angle that lie between 270 and 360, we say is in the fourth quadrant. For example, angle 320 is in the fourth quadrant. We say in the fourth quadrant, only the cos is positive, only the cosine is positive. Only the cosine is positive, the sine is negative. For example, you find sine 320 now. Sine 320 in your calculator is going to give you a negative answer. Cos 320 in your calculator will give you a positive answer. Tan 320 in your calculator will give you a negative answer. Okay, so this is the summary of the four quadrants. Okay, that's the summary of the fourth quadrant. So in summary now, in conclusion now, we can come to this conclusion now. We can come to this conclusion. We say in conclusion, all trigonometric functions are positive in the first quadrant. All trigonometric functions are positive in the first quadrant. All trigonometric functions are positive, meaning what? Sine of any angle in the first quadrant must be positive. Once the angle is in the first quadrant, once the angle is between 0 and 90, all the trig functions will all be positive. Meaning sine of the angle, if you have like sine 70, sine 70 be positive, sine negative, sine cos 70 be positive, and 70 be positive. So sine theta is positive in the second quadrant, and tan and cosine are negative. In the second quadrant, or at the second quadrant, only sine is positive. Only sine is positive. This one says all. All means sine, cosine, and tan. This says was sine. Only sine is positive. Meaning cos is negative, tan will be negative. Meaning if you find angle, if you find any angle that lies in the second quadrant, meaning if you find any angle between what 90 and 180, if you find only the sine of such angle will be positive, cosine of such angle will be negative, tan of such angle will be negative. Right. And for the third quadrant, the third bullet, tan theta is positive in the third quadrant. Only tan theta is positive in the third quadrant, and sine and cosine cos theta are negative. By the third quadrant, by your third quadrant, only tan is positive. Meaning, if you find the angle, you find the tan, you find the tan of any angle in the third quadrant. Meaning, if you find the tan of any angle between 180 and 270, the tan of such angle will be positive. But the cos and the sine of such angle will be negative. Okay. And then lastly, for the fourth quadrant. For the fourth quadrant, cos theta is positive in the fourth quadrant. Sine and tan are negative. So by the fourth quadrant, only cos is positive. Sine is negative, tan is negative. Okay. So now, so here is a useful way to remember this rule of the signs in the quadrant. So quadrant one is all, quadrant two is singles. So all singles take what? Curve suites. All singles take curve suites. So all singer take curve suite. You want to be a singer, you must have a good voice, and then to make your voice nice, you need a curve suite. So you don't have like curve. So you can sing nicely. Okay, so this is just a sort of an acronym for you not to forget that all singer take curve suite. Okay. So now when the first one, start from the first one, all, meaning what? All the ratios are positive. Singer implies what? Sign. Singer indicates what? Sign. So that means in the second one, just go like that. All singers take curve suite. All singers take curve suite. All is positive. Only sign is positive. Singer sign. Only sign is positive. Take refers to what? Tan. In the third quadrant, only tan is positive. And then for the last one, curve suite. The curve means what? Indicates what? The cos. Which means only cos of the angle is positive. So that's just a simple way of knowing them. And if you get any angle between 270 and 360, only the cos of such angle will be positive, the sine, the cosine, the sine, and the tan will be negative. If you have an angle between 180 and 270, only the tan of it will be positive. It has to be negative. So not to forget, just use this. All singers take curve suite. All singers take curve suite. Okay, right. So that's the concept of quadrant. What I initially referred to as what? Cast. C-A-S-T. So if you want to use that, can simply say what? Cast. C-A-S-T. So you must just know where the names of each quadrant, and don't forget this is your first quadrant, all the first quadrant in anti-clockwise direction like that. First, second, third, first. You can say it's cast, C-A-S-T, or you can say all singers take curve suites. Okay, and they must know what this all implies. Okay, hope you understand. Right. Now, so now let's see now. Exercise. In which quadrant does the terminal arm of angle theta lie if sin theta is greater than 0 and cos theta is greater than 0? Again, in which quadrant does the terminal arm of the angle theta lies if, where would be your terminal arm? Which quadrant will the angle be? That is the question. In which quadrant does the terminal arm of the angle theta lie if sine is positive and cos is positive? So which quadrant has it that sine is positive, cos is positive? Which quadrant has it that sine is positive, cos is positive? Greater than 0 means was positive, don't forget. Again, sine theta greater than 0 and cos theta greater than 0 means was positive. Greater than 0 means positive, less than 0 means negative. So this one saying here that sine theta greater than 0 means what? Which quadrant has that sine theta is positive and cos theta also what? Greater than 0 positive. So which quadrant? Which quadrant we have sine positive, cos positive? Which quadrant you can so in this case now, so the first quadrant, and then don't forget when you say which quadrant has sine theta positive and cos theta positive, that means at the same time. That which quadrant at the same time has is the two positive at the same time. Okay, which quadrant has these two positive at the same time? Sine is positive and cos is positive at the same time. So which quadrant? So the first quadrant. Okay, only the first quadrant. I mean the arm, the terminal arm must lie in the first quadrant, because only in the first quadrant, sine and cos are positive. Only in the first quadrant, sine and cos are positive. Here now sine is positive, but cos is not positive. Here now cos is positive, but sine is not positive. But only here has what? Sine and cos positive. So say the first quadrant. So the terminal arm within the first quadrant. Okay. So the next one, B, which quadrant, where be your angle, which quadrant has that sine is less than 0, cos is less than 0. Sine is negative, less than 0 implies negative. Sine is negative, cos is also less than 0, cos is negative. So which quadrant has the sine is negative, cos is negative? Which one has sine is negative, cos is negative? Which quadrant has sine is negative, cos is negative? So which quadrant? Let's see. Let's see who has someone is giving answer here. Let's see there. Let's see there. I can see the chat section. I can see there. Okay. So basically, which one has sine is negative, cos is negative? So that would be the third quadrant. The third quadrant. Okay. The third quadrant. So the third quadrant has what? Sine is negative, cos is negative. Less than 0 So only the third quadrant, sine is negative, cos is negative. So the answer is the third quadrant. Okay. Right. So C says, which quadrant has tan is greater than 0, cos is less than 0? Tan is greater than 0, tan is positive, but cos is negative. So which quadrant has tan positive, cos negative? Which quadrant has tan positive, greater than 0, cos negative? Right? So that would be in the third quadrant. That would be in the third quadrant. Okay. That would be in the third quadrant. Sine is positive, but cos is negative. So where tan is positive is here. Remember, tan is also positive in the first quadrant, but cos is not negative. So person wants where tan is positive and where cos is negative. Tan is positive and at the same time cos is negative. So only tan is positive and cos is negative. So we need third quadrant. So our answer is what? Third quadrant for question 3. Question C rather. Question D says tan is less than 0, meaning tan is negative and cos is less than 0. Tan is negative, cos is negative. Which quadrant has tan negative, cos negative? So that means the sine one, the second quadrant, where only sine is positive. So D is what the second quadrant. So by second quadrant, tan is negative, cos is what? Negative. Negative less than 0 means negative. Okay. So D is what? Second quadrant. So let's see E now. E says which quadrant is what? Sine is negative and theta is an element of what? 90 and 270. Look at that. Which quadrant is sine is less than 0, meaning sine is negative, and at the same time, theta is an element, is strictly an element to 90 and 270. So looking at this, theta being an element of 90 and 270, this only implies what? This only implies the second and the third quadrant. Again, by the fact that theta is an element of 90 and 270, tells us that means theta can only be an angle between 90 and 270. That means theta can only be within what? The second and the third one. So that means theta cannot be what? In the first one. And the theta cannot be in the fourth one. Okay. So theta can only be in the second and the third. So by this other statement, it's saying sine is what less than is negative. So among the second and the third now, among the second and third quadrants, which one has sign negative? Which one has sign negative? Okay, which one has sign negative? So we're saying that that theta is between 90 and 270. So 90 and 270 means there is 90, there is 180, there is 270. So that means theta is somewhere among these two, 90 and 270. So that means theta can be in the second or the third. But we're told that what sine is what negative. But sine is negative. By the other condition, it says sine is what less than 0. The sine is less than 0. That means our answer must be what? Our answer must be the third quadrant. So this is where sine is negative, and then the theta is between what? 90 and 270. So our answer is the third quadrant. Hope you understand that. Okay, right. And then lastly, which quadrant has what? Cos theta less than 0, and at the same time is 0. I mean, 0 is less than theta, and theta is less than 180. So it just says what? If 0 is less than theta, 0 is less than theta, theta is less than 180. What does this mean? It means that what? Theta is greater than what? 0. Again, it reads what? If 0 is less than theta, that means theta is more than 0. If 0 is less than theta, and at the same time theta is less than 180. So because if 0 is less than theta, that means theta must be greater than 0. So basically theta is greater than 0, but theta is less than 180. That means the angle we're talking about is basically between what? 0 and 180. So now we're looking at the quadrants where the angle is between 0 and 180, and at the same time our cos is what? Negative. At the same time our cos is negative. So which quadrant is this referring to? Okay. So for 0 and 180 implies what? Quadrants 1 and 2. 0 and 180 implies quadrants 1 and 2. And then cos negative implies what? Cos negative implies that quadrant 1 cannot be, because in quadrant 1, cos must be positive. Explain that again. 0 theta less than greater than 0 and less than 180 implies the angle must be between 0 and 180. Okay. Now, which means what must be in the first and the second quadrant. So considering this other condition that cos theta must be less than 0. So which of them will it be in the first or the second one? Because it has to be only in one of them. So it can only be in the second one, because by the first one, theta is not negative. Okay. So hope you understand what exactly I'm explaining there. Okay. Let's go a little bit faster now. Now, example 1. Let's look at this now. Example 1. If cos theta equals to 4 5 and theta is an element of 0 and 90, calculate without calculator the value of a tan squared theta. If cos theta is 4/5, right? Cos theta is 4/5, and theta lies between 0 and 90, that means the first quadrant. Without calculator, without the calculator, so find the value of this. So using the diagram here, so this is the diagram here. You did a diagram, you draw the diagram now. You must draw your arm to be in the first quadrant. Your arm of the quadrant, your terminal arm will be in the first quadrant. Why the first quadrant? Because why? Because our theta is less than between 0 and 9. So you're going to draw your Cartesian plane, you draw your terminal arm in the first quadrant to be your theta. Next, along with the positive x-axis, you put your theta here, and then you now have to complete this triangle here. You have to complete this triangle. How do you complete it? Use this relationship that I think cos theta is 4/5. Remember, cos is what? Adjacent over hypotenuse. So with that, to complete this triangle. So if your theta is here, that is opposite, you'll be your adjacent, you'll be your hypotenuse. So you must put what here? That means our adjacent is of 4 and the hypotenuse is 5. Okay. So with that, to complete this triangle, using what? First of all, you need to first tell us where the terminal arm is. The terminal arm is in the first quadrant. Why the first quadrant? Because our angle between 0 and 90. Okay, we have our terminal and there. Then you have to create a triangle, complete the triangle. You have to put values around this triangle. To put values around the triangle, you use this other one, this other statement that cos theta equals 4 over 5. So cos means what adjacent over hypotenuse times our adjacent is 4 and hypotenuse is 5. So from a triangle, what is our adjacent? Our adjacent is this side here, we call it 4. And hypotenuse is this side, we call it 5. So we don't know this one. This side is unknown, so you use Pythagoras theorem to find your y. You use your Pythagoras theorem to find your y. Okay, so use Pythagoras theorem, because here you are 5 here, you are 4 here, you don't know this one. So find the y here, use Pythagoras theorem, and then you can get what? 3. Okay, you get 3. So y is what? Plus or minus 3. Y is plus or minus 3. So now, which one will you choose? So we'll choose the plus 1 or minus 1. Remember, whenever you are finding equal to any number, your plus and minus sign are your solutions. Please understand that if your Pythagoras theorem, your s squared, your hypotenuse squared is equal to your 2 sides squared. To 5 squared. So first squared is 16 plus y squared equals to 5 squared. Move or bring your 25 in. So anyway, you're going to have what y equals to y. I'm going to have y squared minus 9 equals to 0. Okay, y squared minus 9. If you bring the 25 in, then I have 16 minus 25, and that'll be minus 9. Okay, so now you factorize this, you can get plus or minus 3. So that means there are 2 values there. So, but the positive one is our solution. Okay, the positive one is our solution, and then because in the first quadrant, so that means we take positive 3 as our y. That means our y is what? Positive 3. So if y is positive 3 now, then we have completed the whole triangle. And after that, we can now solve for whatever we need to solve for. We need to find the value of tan squared theta. Remember in our previous class, then tan squared theta means what? Tan theta all squared. That's the meaning of tan squared theta. So tan squared theta means what? Tan theta, then squared. So what will be our tan theta here? Tan will be opposite y over adjacent 4. So our y we said is what? 3. It's plus 3. So 3 over 4 all squared will give you tan squared theta. And that'll give you 9 over 16. So basically, tan squared theta is what? 9 over 16. Okay. Okay. Tan squared theta is what? 9 over 16. Okay. So let's see quickly the last example for today. Right. Example 2. If 3 sin theta equals minus 5 and theta is between an element of 90 and 270 degrees, calculate without calculator and with the aid of diagram. Calculate without the use of calculator and with the aid of a diagram. That means you must draw your quadrant. The word with the aid of diagram means you must draw your quadrant. The value of cos theta plus sin theta. Okay. So now you must draw your diagram. So why do you draw your diagram? Draw your Cartesian plane, your y-axis and your x-axis. So now to check now, where will you put your triangle? Where will your triangle be? The first one, the second one, the third one, and the fourth one. You need to check what you're given. They said our theta must be between 90 and 270. So 90 and 270 is what? There is 90, there is a 270. That means theta can be anywhere around here. Theta is an element of 90 and 270. That means theta can be anywhere around here. But if you look at the other side here, if you're trying to make the sign, if you want to try to isolate the sign, try to make the sign the subject of formula, you're going to do that by dividing both sides by 13. So your sin theta will be minus 5 over 13. Again, your theta is minus 5 over 13. So that means your sign is negative. That means the sign is negative. So among these two, which one is sign negative? So it's in the third one, because in the second one, sign is negative. That means our triangle will automatically be in the third one. Okay, the third quadrant. So you're going to draw a triangle here, and then now put your sign. Remember your sign we said got minus 5 over 13. And sign is opposite minus 5 over hypotenuse 13. So now with that, with the minus 5 and 13, you try to complete this triangle. Sign is opposite. So this is theta here, always with your x-axis. Then it be your opposite. This side is opposite, which is minus 5. And then your hypotenuse is always your here, you put your 13. And then Pythagoras to solve for x. Once you solve for x, then you can calculate your cos theta and sin theta. Okay, so because of time constraints, we'll be able to go into more detailed example. So so we're going to carry on from there next class, but this one is a take away question for us to practice on. So let's try to take a picture of this. Let's try to see how to, because practice makes perfection. Let's try to prepare on this and see how to understand this topic better. Okay. All right. And then our next topic, in our next topic, we'll be looking at reciprocal of trigonometric ratios. So next topic about reciprocal of trigonometric ratios. So please attend for tomorrow's class where we're talking about reciprocal of trigonometric ratios. So thank you for attending and enjoy the rest of your day.
Guys,